Hello, Honors Algebra 2. Today we'll be looking at the Edgenuity section 8.5 called Adding and Subtracting Radicals. There are two objectives to this section. The first is to add and subtract radical expressions, and the second is to identify like radicals. So let's start by trying to identify which ones are the like radicals. So I'm going to put a check next to one, and the idea is the part inside the radical, inside the root, has to be exactly the same, except that we have to remember that maybe multiplication can be done in any order. Okay? So, see how this one and this one, the insides are exactly the same, and in fact that one, the insides are exactly the same. So those three, I can say, are exactly the same. You can completely ignore the stuff out here in front. That does not matter when we're looking for like radicals. Okay? However, look at this one. The squared is on the y, so that is not one. Look at this one. The squared is still on the x. There's no square with the y. And it's just this one mixed up, right? You could still write it as x squared times y, because multiplication is commutative. You can write it in whatever order you want. So that is also a like radical. Then look at this one. They both have squareds, so definitely not that one. All right, I'll let you look at that for a moment. And let's move on to the next board. Next question is, what is the radical part of both cube root of 54 and cube root of 128 when simplified? Okay, so this takes some exploration. Let's look at 54 and do what they call factor tree on it. It's an even number, so I can divide it by 2. 54 divided by 2 is 27. 27 is 3 times 9, and 9 is 3 times 3. So I get 54 being 2 times 3 times 3 times 3, 3 times. So 2 times 3 cubed. And I'll talk about why that's significant. Let's do the same with 128. It's 2 times 64, which is 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So, how many 2's have we got here? 1, 2, 3, 4, 5, 6, 7 of them. There's all 7 of them there, so this can be called 2 to the 7th power. Okay. And now we want to look at it in such a way that we can take cube roots. So the cube root of 2 times 3 to the third is the same as the cube root of 2 times the cube root of 3 to the third. And a nice little fact is that the root, if the power's the same, they cancel each other. So this is the cube root of 2 times, if this cube root cancels the cube, then you're left with just 3. It basically cancels the radical. Okay. Same thing here. You got the cube root of 2 to the 7th. What if I called that the cube root of, and I started taking out as many cubes as I could. So 2 cubed and another 2 cubed. That's 6 of them, and so for the 7th I'll just leave a 2, which is the cube root of 2 cubed times the cube root of 2 cubed times the cube root of 2, which gives me the cube root and the cube cancel each other, give me 2, cube root and the cube cancel each other, give me 2, and times the cube root of 2. So this gives me 4 times the cube root of 2, and over here I've got 3 times the cube root of 2. So the radical part of both of them is the cube root of 2. I'll pause for a moment, let you look at that. And let's move on to the next board. All right, let's add 2 of them. So look at what we've got here. We've got like radicals, square root of a and square root of a. Not only that, but I have like terms, and what you should really be looking at here is that the variable parts are exactly the same. So really what I've got here is like terms. So I can essentially factor the like term part out to the front and have just 6 plus 7. This is why you can add things with like terms, okay? And then that would be y times the square root of a times 13, which you would write as 13y times the square root of a. And there we have it. I'll pause for a moment, give you a second to look at that. All right, let's go on to the next board. Now let's subtract them. Now, this time we don't have like radicals, right? We don't have like terms. So let's break things down and write them in better ways. Let's break down 20. 20 is 4 times 5. 4 is 2 times 2, so that's 2 squared times 5. 80 is 2 times 40. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So that's 2 to the 4th times 5. So let's see what we have now. Now we have the square root of 2 squared times 5 minus the square root of 2 to the 4th times 5. So last time I was breaking things down one way. I'm going to break them down a slightly different way this time to remind you of something from a previous section. Okay? So I can still split apart these multiplications. That's square root of 2 squared times square root of 5 minus square root of 2 to the 4th times square root of 5. Now look at these two. These two I could write with fractional exponents. Okay? The square root tells me there's a 2 on the bottom of the fraction, and that exponent tells me there's a 2 on the top of the fraction. So 2 over 2 times the square root of 5. I could write that with a fractional exponent, but there's no good reason to. Same thing here. 2 on the bottom, 4 on the top this time, so 4 over 2 times square root of 5. And then 2 over 2 is just 1, so this is 2 to the 1st. So it's the same thing. The squared cancels the square root, or 2 divided by 2 is 1, times square root of 5, minus, now, 4 divided by 2 is 2, so this is 2 squared, times square root of 5. So that's 2 times square root of 5 minus 4 times square root of 5. And so I could factor out the square root of 5 and have 2 minus 4, which is square root of 5 times negative 2, which I could write as negative 2 times square root of 5. Or you could have just done 2 minus 4 times square root of 5, right? I'll pause for a moment, let you look at that, and let's move on to the next board. All right, let's talk about simplifying something even more complicated, okay? We got a 5 here that doesn't break down. We've got x cubes here, which we have a strategy for. And then we've got these numbers here, 405 and 80. Let's see if we can do something with those, okay? 405 is 5 times 81. Well, 81 has a square root. So I'm going to actually just leave it like that because that'll help me out. And 80 is 5 times 16, and 16 has a nice neat square root, so I'm just going to leave that like that. And these x to the thirds, I'm going to actually write as x squared times x. So I can cancel the square root and the square. I'm also going to split all these multiplications up. So x times square root of 5 times square root of x times square root of y to the 4th. I'm going to have to squeeze all this in. Plus square root of, instead of 405, it's going to be 5 times 81. Maybe I'll just split that into 2 now. So square root of 5 times square root of 81 times x cubed. Instead of calling it x cubed, I'm going to call it x times x squared and split that up. So square root of x times square root of x squared times square root of y to the 4th, and we'll see how we deal with that, minus I'm going to have to put that down here, minus square root of 80, which is square root of 5 times square root of 16 times square root of x times square root of x squared times square root of y to the 4th. So now let's simplify everything that we can. And let's put together everything that we can. So here, square root of y to the 4th. I'm going to have to do that several times, so let me do it once over in some side work here. That is the same thing as y to the, y to the 4 over 2, which is the same thing as y squared. So every one of these square root of y to the 4th becomes y squared. These two I can't do anything with, so I'll just combine them, put them back, and I'll have x, that x right there, times y to the 2nd, times the square root of 5x, because I'm just combining these into one square root again, plus. So now I can call that square root of 81, I can call that 9. Square root of x squared is just x. Square root of y to the 4th is y squared. And then this square root of 5 and the square root of x can be combined back into one square root, minus square root of 16 is 4. Square root of x squared is x. Square root of y to the 4th is y squared times the square root of 5 and x put back together. And so now I have this part that I can factor out of each thing, right? X, y squared times square root of 5x. If I factor it out of the first one, I'm left with a 1. If I factor it out of the second one, I'm left with a 9. If I factor it out of the last one, I'm left with a negative 4. So let me call that plus negative 4 instead of minus 4. And so I have x, y squared times square root of 5x times, well, 1 plus 9 is 10. 10 plus negative 4 is 6. So I can call this 6xy squared times the square root of 5x. And there's my answer. I'll give you a moment to look at that. And we've got one last problem to go through. Let's look at that now. If I ask you to find the perimeter of a shape, as long as I'm not asking you to find the perimeter of a circle, which is the circumference, the perimeter of any other shape is just adding up the sides, any shape with sides. So if I ask you to find the perimeter, I'm just asking you to add up all these sides. So that's 2 times square root of 27 plus 2 times square root of 12 plus 3 times square root of 3 plus the square root of 12. Well, let's see if we can get something common out of these numbers in the roots. So let's break down 27. It's 3 times 9. 9 has a square root. I'll leave that way. 12, that's about 3 times 4. And 4 has a square root. And then 3, I don't need to break down because there's no way it's only 3 times 1. It's a prime number. So let's call this 2 times square root of 3 times square root of 9 plus 2 times square root of 3 times square root of 4 plus 3 times square root of 3 plus square root of 3 times square root of 4. Alright, well, now I can start simplifying things like that, and that. So that's, this is square root of, the square root of 9 is 3, so I got 2 times 3 times square root of 3, plus this is 2, so I got 2 times square root of 3, then 3 times square root of 3, that doesn't change, plus this is 2, so 2 times square root of 3, which gives me 6 times the square root of 3, plus 4 times square root of 3, plus 3 times square root of 3, plus 2 times square root of 3. And then these are all like terms now, so I can just add up the numbers. 6 plus 4 is 10. 3 plus 2 is 5, so 10 plus 5 is 15 times the square root of 3. Now I did that a little bit faster than the other ones, but I hope I've shown you that that just involves factoring out the square root of 3 and adding the numbers, then putting everything back together. Alright, I hope this has been helpful. Thank you. This ends this section.